hypothesis testing of the population mean. A random sample is taken from a normally distributed population with a standard deviation of 14.3. So we have these sample values. We're going to test at the 5% significance level to see if the mean exceeded 46.7. So the null hypothesis, H0, the population mean is equal to 46.7. So H1, the population mean, is greater than 46.7. The sample mean can be calculated by adding up these values and then dividing by 7, which I've done here. 64.29. 64.29. The test statistic is given by Z using this formula straight from the formula book, putting the values in. 64.29 minus the population mean, 46.7, divided by standard deviation, which is 14.3, over the square root of the sample size n. That value there, that's on the calculator from the sample mean. If I just store that, so shift store A, that's now stored in the calculator's memory. Fraction alpha A, that's the sample mean, stored in memory A in the calculator, minus 46.7 over fraction standard deviation over the square root, the sample size, 3.25. Okay, so Z is equal to 3.25. Sketch the standard normal distribution. We're looking for 5% shaded to the right. 5% here, 95% here, so we need the Z value, this critical value here, the Z value, going to table 4 from the formula book. Page 25. Zero 0.950, 1.6449, 1.6449. This is the critical value. Our test statistic Z is 3.25. So 3.25 on here takes us into the critical region. And because the test statistic is in this shaded critical region, our conclusion will be reject H0. There is significant evidence that the mean, and you can put the context of the question here, the mean of whatever that the mean has, and we were looking for an increase, that's what we're testing for. has increased. Okay, so there you go. That's the only hypothesis test that appears in S2. All of the remaining hypothesis tests are in S3. So going over the basics again, you need your H0 and H1, and make sure you don't make mistakes like this. H0 equals 46.7. You'll get no marks for this whatsoever. Use the same value that you've used in H0 for H1. If you want to, you can write this out in words rather than using symbols. If you write it in words, make sure you use the word population. Okay, so H0 and then in words, population mean equals 46.7. H1 population mean greater than 46.7. Work out your sample mean, and this has to be a random sample. If it's not a random sample, then you're assuming it is a random sample. The population must be normally distributed. For a small sample, if that was not given to you, so if that wasn't stated, you would assume that the population is normally distributed. For large samples, it doesn't matter. You know about the central limit theorem. That steps in. You work out the test statistic using this formula here. This formula is on page 12 of the AQA formula book. Here we go. So there's no need to memorize this. Okay, so put in the values, work out your test statistic Z, do a sketch of the normal distribution, then draw this line, and it depends on whether you're testing for more than, less than, or whether it says not equal to. If it says not equal to, you will have two of them for a two-tailed test. This is a one-tailed test. There's only one shaded region. Mark your probabilities. Look up your probability, so 95%, and that was on page 25 there. Check to see if your Z value is positive on the right hand side or negative on the left hand side. So that line there would have been minus 1.6449. Mark your test statistic on the sketch, and if you're in the shaded region, so if the TS value falls in the shaded region, you reject H0. And if you're rejecting H0, so you're rejecting this, you're saying, I found evidence that the mean has increased. And then give a conclusion within the context of your question. So there is significant evidence that the mean, this is where the context goes, that the mean of whatever has increased.